We're going to take a look at P6-23. Our instructions are to create an assembly drawing. To do that, we need the parts, and then we need to assemble the parts, and then we can make the drawing. We'll do the animate assembly as an optional add-on. And then the exploded isometric drawing, the exploded view lives inside of the assembly, so we do not need a separate file. I often get two files and then you have to manage two files and it just doesn't work that way. So having a configuration and an assembly in that or a exploded view in that assembly in that configuration is the best way to manage it. The bill of materials can be inserted into the assembly, but it's kind of noise in the background. The bill of materials really goes to the drawing. So taking this in order, we have M6 by 1, 60 millimeters long, 6 inches or 6 millimeters in diameter. So we'll be opening up our metric part. And so it looks like the drawing we're working from, I'm going to start in the right plane. And it still doesn't matter, it's just we're starting to build in design intent. And the design intent is when I bring this in the assembly, it may or may not be at this point, but it will probably be helpful to have the same orientation. Now that I think about it, and this one probably not. What would be helpful though is to do the features, and when we extrude this, to extrude it mid-plane. That way that right plane is available to act as a mating reference in the assembly. So 6 millimeters and nope, 60 millimeters. There we go. And we accept it. All right, and then for this one, we're going to do cosmetic threads. I'm going to do the feature threads. I'm going to do a video on thread, I would say theory, thread rules, and go through some of the more complicated parts of the threads. I'm fascinated by threads, so just like talking about threads. We're going to insert then, and it is just off the screen, so I don't see it, and I don't have annotations. Do we have an annotation? No, not really. Just seeing if there's someplace else, but at the bottom of this, and then it pops up, and right at the bottom of the screen we have cosmetic thread. All right, so we'll do this one this way, and if I am not making it clear, we'll also come up to the search and do it that way. So when I pick the major diameter, all right, an edge, and it's asking me for the minor diameter, the quick and nice thing about metric is 6 minus 1 is 5 millimeter. Now the actual machine threads and form threads may be a little bit different, but as a general rule, we can get away with just subtracting the pitch from the diameter and ending up with the minor diameter. So we want a blind in condition and 10 millimeters, and we'll accept it. All right, so we don't really see anything have this kind of minor diameter there. If I look at it from the front though, then I get the simplified thread form, and that's what we're working towards. All right, so if I go to my search and go to commands, then I can start typing if I can figure out how to spell cosmetic. All right, so when we click on cosmetic thread, it takes it right in there. The other thing, if I'm doing enough of these, let's see if it'll let me switch. Doesn't look like I've added it, so we'll finish out this function, and then I'm going to add it to the list because I'm going to do this a couple more times. So 5 millimeter blinding condition, 10 millimeters should be good. We'll go ahead and accept it. And then the last thing is to add the chamfer. And if I can control select chamfer, this is 1 millimeter by 45. Get the preview on the one end. Looking at it from the end, that's going to be everything we need to detail. So I do not have an assignment going for this one just yet. So I will create a new folder in my projects folder, and we're going to go with A5. And because I haven't really set up a naming convention, I'm just going to go with Vise handle. We could do part numbers. Most organizations have some kind of naming scheme. It just depends, for me, it just depends on the project. So we're going to kick this one out, and we'll go ahead and stay in order here. Close that guy and pull this one up. All right, so main difference with this one, with our lead screw, is going to be that we have all of these different diameters. So I'm not overly concerned with the chamfers. And if we look at that one's a straight. And if we look at the M12 by 1.75, there's not an undercut, and we'll talk a little bit more about the importance of a relief or running it off the end. But this really lends itself to a revolve. So looking at it from the front view, if I cut this in half and draw a profile that is pretty much like that, that's going to give me the most geometry out of that one sketch, rather than drawing a circle and extruding it out 25 and then drawing a circle and extending it out 120, 124, and then a 9, and then a 5, all of those. So we want to take advantage of that geometry. So in the front plane, we'll go ahead and open up a sketch. And because I'm going to revolve, we're going to go right into center line. And this is going to be a horizontal center line, infinite length, and set it right on the origin. When I accept it, I usually find that it's easier just to accept it or escape out of it than it is to try to reset those parameters to get what I need. So we go into line. It's going to be as sketched, and we're going to start drawing. And I'll get the basic profile in. I'm not worried about the chamfers at this point. I just want all of my geometry. All right, and it doesn't even have to be that close. I'm just looking to have the basic profile. All right, and the last thing is I want to close this off. So once it becomes a region, if I don't, when I perform the revolve, it's going to ask me to close it off. The only problem with that is sometimes it doesn't close off the way that I expect or the way that I want. So first dimension should scale everything, so that looks pretty good. And we'll go to M12. All right, so when we look at that call out, M12 by 1.75, the M12 is the major diameter, so 12 millimeters, and we'll worry about the pitch later. All right, so M12, and then we have a 6 millimeter and an 8 millimeter. So since it jumped out of, but since I'm in the diameters, we'll kind of keep doing the diameters, because it will stay in that mode until I hit escape. All right, that puts me back into, and as long as I can see that dimension symbol next to my arrow, I'm going to stay in dimension mode. If that goes away, then I'm in selection. All right, 139 is the overall. We have 5 millimeter at the end and 9 millimeter and grab the midpoint, so escape to get out of it, and as long as I'm still in dimension, I just reselect, go again. Alright, so a couple of, oh, that one would do it, 25. I'm going to say a couple of blue dots, which usually means that I missed or did not get a relation, so I could go ahead and make that the chamfer, or we can just go ahead with making that vertical. Alright, so that puts us into a fully defined sketch. And when we jump into the features, we're going to revolve boss base and hit accept. Alright, so that gives us our base geometry, and it says that all of the chamfers are 1 by 1, so 1 by 45 degrees if we go that route. So select, control select, control select, control select. And then we're looking for the chamfer, and it's also available on the right mouse button. 1 millimeter and accept. Alright, so on the previous handle, we put the cosmetic thread in prior to the chamfer. The order doesn't typically matter, so as long as I have an edge, then we'll be able to work with. So I did not, let's see, on the sketch, I'm going to make sure that I can see that since I'm going to do this a couple times. Make sure that I'm not overwriting cosmetic thread, and I'm just going to drag. And let's see if we can do that again. And that was what I was trying to avoid previously, cosmetic thread. You left click, hold down, and you can drag it into your menu. And now it's available to pick from the sketch command manager. Right, so thread settings, we're going to pick that edge. And let's tell it to go up to next. And the minor diameter, M12 minus 1.75, is going to put us at 10.25. And it didn't jump into the metric, but notice if we go into metric, we can call out the thread class. So this is still in inch apparently with the 1A, 2A, and even with the ANSI metric. So the metric system uses the 6G, 6H as a typical. The thread call out I don't usually use, so if we've gone that route, mainly the M12 by 1.75, and it made the minor diameter, let's see, 0.08 would be about, what, 3 thousandths? Anyway, it made it a little bit larger to work from. So again, we don't see anything per se. There is geometry, and I can see the minor diameter, and it goes up to there. Now, in manufacturing this, if I'm running a die, a thread cutting die down this shaft, there's going to be a spot at the end where the thread leads out. If I am doing a single point thread on a manual or a CNC lathe, and as that single point goes across and forms the geometry, if there's a little relief, that usually helps. But if it just feeds out, there's a spot to where it won't necessarily go right up to the face. So that's the decision mode, is do I need this to bottom out on that face? All right, and then the last piece of geometry is, oops, I forgot the hole through. So looking at the rollback bar, as I go across, I get the little fingers I can roll back, and it treats that chamfer as if it wasn't there yet. So I can go into the front plane, open up a sketch. We're going to find the whole location. So it did not apply a horizontal, so a quick control select horizontal into the dimension. So you notice I'm not getting out of getting out of those commands to go into another command, I am just continuing on with the next command. So dimension from the side, if I always wanted this to be center, I could have done a center line and put that point at the midpoint, and that would do the same thing. So we've got the 12.5. We're going to extrude cut, and this becomes a through all both. Because it's sitting in the middle of the part, if I don't turn on both, I'll only get one side of the cut. All right, and then we grab that rollback bar and drag it forward, drag it back. All right, there, not there. All right, so this is the vise lead screw. And we'll pick up with the vise body on the next video.